So van der Waals equation is a modified PV equals nRT. So we modify the factor pressure because we have to correct pressure now. But we have a high pressure, so to correct the pressure, what I did is pressure, and then here's my addendum is my A times my N squared, which is moles, divided by volume squared. So that's my addendum for my pressure. Also, we have to make an addendum for the volume because gas particles now are no longer negligible. So now the volume is minus moles times your B. Now you get A and B from table 5.4, and I will actually provide those for you on the test. So let's actually look at this equation, do a comparison between PV equals nRT and our modified. So with this, we have calculated the pressure exerted by 19.5 moles of nitrogen at a 1.25 liter container at negative 40 degrees Celsius. Now, first of all, using the ideal gas law, you've been used to this. You have moles, you have volume, you have temperature, you have R, plug and play, and you can calculate the pressure. So in this situation, when I say pressure, you're going to divide both sides by volume. And I gave you volume, I gave you moles, I gave you temperature. The only one you have to work with is temperature. Make sure it's in Kelvin. So you multiply across, you divide by 1.25, and you get a pressure at 298 atm. However, let's take a look at van der Waals equation. Now in the situation, you realize you're at low temperature. We're at negative 40, so we're at a low temperature. So in the situation, we'd anticipate a high pressure. So van der Waals equation, we actually plug it in. And here's van der Waals equation. We plug in our A, which I gave you in the top of the column there, 1.39 atm times Z squared divided by mole squared. And then you divide it by your volume squared, so 1.25. I give you that in the problem. And then times, that was your modified pressure, times your modified volume. So volume is 1.25 minus moles times B, and equals nRT. And so in this process, a little more math involved with it, actually simplifying the process out, and you end up with 427 atm. So as you can actually see here, van der Waals equation was more accurate because we had low temperature to anticipate a high pressure.